Yes. Good afternoon, students. So today I'm just going to start with the first lecture of seventh semester for the subject non-conventional energy sources, right? And in this lecture, I will give you brief introduction regarding the syllabus, and after that, we will discuss some different types of the non-conventional energy sources and limitations of the conventional types of the energy sources. That means why we need this non-conventional energy sources. So first of all, I think you must aware that what are the conventional types of the energy sources and what are the non-conventional types of the energy sources. So whenever we will discuss about conventional types of the energy sources, right? In case of this conventional types of the energy sources, we will deal with that hydropower electrical plant or that thermal power plant, nuclear power plant, right? So these are different types of the conventional types of the energy sources, right? So in case of the conventional types of the energy sources, what is the need? What is the need of the future? First of all, you must aware that need of the energy I am talking about electrical energy, that is just going to be increased day by day, because we are putting a lot of different that instruments or load on the electrical lines, because the number of industries are going to be increased, number of home appliances are going to be increased. If you see the 10 to 15 years before, then what will happen? Number of the air conditioner in your locality are very much less, but in present, I think in each and every home there are more than one air conditioner, depending upon the requirement or depending upon the number of rooms. Each and every home is having number of air conditioner. That means if you are aware that these air conditioner are having a huge load on the electrical network. Similarly, other types of the devices will also put the load on the electrical network, like washing machine, television, or some other devices may be also considered under the same, right? So what will happen that number of electrical appliances are going to increase. Number of electrical appliances are going to increase day by day, and this will increase the load on the existing electrical network, right? But our present energy sources, that means I am talking about coal, hydropower plant, nuclear power plant, or maybe some other type of the conventional type of the energy sources, that energy sources are not able to fill our day-to-day demand even, and again our load is just going to be increased day by day. That means either we will have to find some more sources of energy, either we will have to find some more sources of electrical energy, or second option is we will have to shift towards the non-conventional sources of the electrical energy, right? First of all, you must aware with the basics that energy can neither be created nor destroyed. Energy can neither be created nor destroyed. It can be converted from one form to another. Right. So that means there are a lot of energy sources present around us. Solar energy, wind energy, tidal energy, biomass, biogas. These are some general kind of the non-conventional sources of electrical energy. Right. So if by any mean we will be able to convert our these non-conventional sources energy into electrical energy, then it will be very beneficial for the human being. Right. It will be very much beneficial for the human being because our load will not going to be stopped even after decade or even after 2 decades. Load is just going to be increased day by day. Right. So what is the need of the non-conventional types of the energy sources? Because our load is going to increase. Our load is going to be increased day by day. To fulfill the demand of the electrical energy, we will have to shift from conventional sources of energy towards the non-conventional sources of energy. Right? Then in this lecture, I will take just introduction of the syllabus. Then after that, this different types of the energy sources, just introduction again, and limitations of the conventional energy sources. We will discuss it one by one. So in part 1 of the syllabus, there are 2 chapters. One is introduction and second is MHD generator. Right? One is introduction and second is MHD generator. So in introduction part, we will discuss just limitations of the conventional types of the energy sources, need and growth of the alternative energy sources. Alternative energy sources means non-conventional again, because presently we are dealing with conventional types of the energy sources in most of the time, or you may say about 70 to 75% of the energy fulfillment is through the conventional types of the energy sources only, right? But because of the present scenario, we will have to shift from these conventional types of the energy sources towards the non-conventional types of the energy sources, right? So after that, we will just study basic schemes and applications of the direct energy conversion, right? These parts we will discuss under non-conventional energy sources. Then first chapter, that means introduction of the non-conventional types energy sources. Introduction of the non-conventional types energy sources. Then after that, second chapter of the first part, that is MHD generator. MHD generator, right? So MHD stands for magneto hydrodynamic. Magneto hydrodynamic. right? What is MHD? MHD is magneto-hydro type electrical plant or electrical generator. Now, what will happen during this case? In journal, again I am repeating, this is just the journal lecture about complete syllabus. We will discuss each and every topic in detail, right? So, in journal that alternator or generator, what is the basic principle? Faraday's laws of electromagnetic induction, right? In journal, what are the journal basic principle of the generator or alternator? That is Faraday's laws of electromagnetic induction. What are Faraday's laws of electromagnetic induction? It states that whenever Faraday's laws of electromagnetic induction, whenever there is a rate of change of flux, an EMF is induced across the coil or conductor. There are two laws of the Faraday's. One is first law. First law states that whenever there is a rate of change of flux, an EMF is induced across the conductor, right? So that means whenever d phi by dt is there, it will cause for the induction of the EMF across the conductor coil, right? Similarly, what is the second law of Faraday's? What is the Faraday's second law? Amount of the EMF induced is directly proportional to rate of change of flux. In first law, what we say that EMF is induced whenever there is rate of change of flux. And what is the second law? Amount of the EMF induced is directly proportional to rate of change of flux, right? So depending upon these Faraday's laws, we are having a conventional electrical generator. What we are having? We are having conventional electrical generator. In case of the conventional generator, there is a electromagnet or there is a permanent magnet. One north pole and another is south pole, right? So whenever due to electromagnet or due to permanent magnetism property, whenever that flux lines are there, that means whenever flux is there, then after that we will just place the coil or conductor in between the north and south pole, and with the help of some mechanical mean we are just going to rotate that conductor or coil, and whenever that conductor or coil will rotate, it will cause for the induction of the d phi by dt, right? Induction of the d phi by dt, and due to rate of change of flux d phi by dt, EMF is induced across the coil, right? But in case of the MHD generator, that means in case of the magneto-hydrodynamic generator, what is the difference between two? First of all, basic principle will remain same. Basic principle that will remain same, right? That means what is the basic principle of MHD generator? That is Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction is also the basic principle for MHD generator. We had already discussed it, right? What is Faraday's laws? Yes. In part 2, we will just discuss thermoelectric generator, right? For that, we must aware with thermoelectric effect. One effect which you had already studied in your previous classes in 10+2 level, even Seebeck effect. What is Seebeck effect? Whenever two dissimilar metals are joined together at a different temperature and EMF is generated across it. So in part 2, we will study thermoelectric generator. In thermoelectric generator, we will discuss various thermoelectric effects like Seebeck effect, Peltier effect, Thomson effect, right? Then after that, by the use of these effects, we will study thermoelectric generator, its application, and then after that, its economic effect, right? Then in part 3, we are having photovoltaic effect and solar energy. In photovoltaic cell are nothing, these are PN junction, right? Simple diode with some special types of the material which may be having a breakdown in its that PN junction. Whenever some solar energy will just fall on it, right? And then after that, in part 4, we will discuss some fuel cell. This is again one other type of the non-conventional type of the energy sources, and then some miscellaneous sources. In miscellaneous sources, we are having a hydroelectric plant, wind plant, tidal energy, and biomass energy, right? So, as far as this book is concerned, you may refer GD Rai, non-conventional energy sources, Khanna publisher book, that is GD Rai. It is easily available in market as well as in this particular library. Fine. So we will discuss all that one by one. Yes. Now in part 1, as I had already told it to you, there are two parts. One is introduction and second is MHD generator. In part 2, we will study thermoelectric generator, and in part 3, we will just discuss photovoltaic cell and solar energy. Then in part 4, we will discuss fuel cell and some other miscellaneous sources, right? So in part 1, we will study introduction and MHD generator, right? What are the different types of the MHD generator? First of all, what is the basic difference between the conventional type of the generator and this MHD generator? In case of the conventional types of the generator, we are having a solid conductor, whether that will be a single conductor or that will be a into the form of some coil, right? That means whenever we will just place this conductor in between this magnetic lines of field, and with the help of some mechanical mean, if we are just going to rotate it, then what will happen? An EMF is induced across the coil. In case of this MHD generator, instead of that this ordinary conductor, we are replacing it with the help of conducting fluid, right? This will be just ordinary conductor will be replaced with the help of conducting fluids. That means conducting fluid will be just passed in between the magnetic lines of field. That's all that principle that will remain same, right? Whenever that conducting fluid will be just passed through north and south pole, then an EMF will be generated across the ions of that conducting fluids, right? that we will discuss in detail. Then after that, we will discuss different types of the MSD plants, open cycle and closed cycle, right? And then after that, applications as well as economic aspects of the MSD plant. Whenever we will discuss application of the non-conventional types of the energy sources, these are not more reliable, right? These are not more reliable. These are not available for 24/7. These are not available for 24/7, right? So what will happen, because these are available with time to time depending upon the availability. So we are not using these types of the energy sources for 24/7. These are used in addition with the existing conventional types of the energy sources. Let us say for 17 to 20 hours we are using conventional type of the energy sources, and for rest of the 4 hours we may fulfill our demand with the help of non-conventional types of the energy sources. We are not able to shift from the conventional sources of the energy towards the non-conventional sources of the energy. Right? We are not able to shift from the conventional type of the energy sources towards the non-conventional types of the energy sources permanently. Right? But because of the increase in the load demand, we will be able to serve the load for small period of time with the help of non-conventional sources whenever they are available to us, right? So my mean to say is, whenever we will discuss some applications of the non-conventional type of energy sources, these are only for the special cases. These are only for special cases or not in the ordinary condition. So these are generally used wherever no conventional sources of the energy are available, right? Faraway places, which are faraway places from the ordinary society. Wherever we are having availability of the conventional types of the energy sources, these sources may or may not be used, right? Answer these polls, then we will move further. Yes, please. Now, in part 2, we are having thermoelectric generator. Right. In thermoelectric generator, before starting the thermoelectric generator, we will discuss various types of the thermoelectric effects like Seebeck effect, Peltier effect, Thomson effect. Right. These are various laws or various effects which may be that utilize to convert any non-conventional types of energy into electrical energy. Right. So we will just discuss various types of the thermoelectric effects. Then after that, application of the thermoelectric generator. Again, this may be utilized under some special cases like wherever there is no energy available for the electrical that from this conventional type of the energy sources, then we are just going to utilize this non-conventional type of the energy sources, right? Then after that, in part three, we are having photovoltaic cell and solar energy. So in case of the photovoltaic cell, what are the photovoltaic cell? These are simple p-n junction coil, p-n junction that which will be fabricated from special type of the semiconductor material, right? In ordinary case, what will happen whenever some biasing will be done? That means forward biasing or reverse biasing. I'm just talking about forward biasing condition. In case of the forward biasing condition, an node is connected with the positive terminal of the supply and cathode is connected with the negative terminal of the supply. So whenever this will happen, a node is connected with positive terminal and cathode is connected with negative terminal, then in that particular case, what will happen? That your diode is said to be in forward biasing condition and it will start conducting because the layer in between the p-n junction that will just break, right? In that particular, this is the case of the ordinary p-n junction. But whenever I'm talking about the photovoltaic cell, here that junction will be break due to fall of the solar energy. Due to fall of the solar energy on this junction, right? Whenever due to fall of the solar energy, junction will break and diodes start conducting, that type of the cell are known as photovoltaic cell, right? There is no other difference between the ordinary diode and this photovoltaic diode. Both are p-n junction. The difference is only for the material. In case of the ordinary diode and in case of the photovoltaic cell or photovoltaic diode, material used are different. In this case, junction will be break due to falling of the solar energy across that junction, right? Applications, whenever this some solar energy is available, whenever some solar energy is available in small voltage, if we want to increase this voltage, that maybe cells may be connected in series, right? And if we want to increase the current, cells may be connected in parallel. So depending upon on the requirement, because in your surroundings also number of solar cells or solar panels are available, right? There is huge scope for even job in this area, in the area of the solar panel, right? Then after that, fourth part is fuel cell and miscellaneous sources. Fuel cells, these are simply cells in which some chemical energy is converted into the electrical energy. Some chemical energy is converted into the electrical energy, right? So these may be utilized to induce somewhat electrical amount of energy, and again this energy may be utilized in special cases, right? In addition to that, in fourth chapter we are having geothermal energy, wind energy, tidal energy plant, and biomass energy plant. Geothermal means inside the earth there is a great energy available always, right? So inside this sources, inside this earth, near to the core of the earth, all that metals will be available into the form of molten state, right? Due to some special condition, when that molten state metal will just relieve, this will produce a high energy, and by any of the means, if you will be able to convert that high energy into the form of this electrical energy, then that kind of energy is also useful for us, right? Wind energy, I think you must aware with the basics of the wind energy. Then after that, tidal are in whenever some tides will be produced, that energy will be converted into electrical energy, biomass or biogas. These are another kind of the this non-conventional types of the energy sources, right? Yes. Now, first topic of this syllabus, different types of the non-conventional energy sources, right? Uh, what are the conventional types of the energy sources? First of all, that are petrol, diesel, coal. These are conventional types of the energy sources, right? These are available in market now for very less time period, right? If you study after some time period, these sources of energy like coal or petrol, these are just going to be diminished day by day, right? These are just going to be diminished day by day. So again, the thing is, whenever need of the electrical energy is going to be increased day by day, and sources are limited, right? Sources are limited. So what will happen? We will have to shift from the conventional types of the energy sources towards the non-conventional types of the energy sources. Right? So some of the non-conventional types of the energy sources are solar, wind, or tidal, biomass, biogas, right? These are some types of the some different types of the non-conventional types of the energy sources. Then what are the limitations of the conventional sources of energy? One is limited reach, right? That means whenever these sources are available for some of the time period, right? Whenever, if you are talking about coal, it will take a very long time period to produce a coal, right? So that means if there will be no forest, then these sources are no longer available, right? These sources are no longer available. So that means these sources are available for not a long time period. After some time period, these sources are just going to be diminished. Then after that, second limitation, that is very costly production cost. In case of the solar energy, production cost is very much small, right? Production cost is very much less or very much small in comparison with the conventional types of the energy sources. Petrol, that is very costly, diesel very costly, nuclear fuel that are costly. So whenever I'm talking about the conventional sources, in that particular case, cost factor is also considered. right? Conventional sources are costly. It is very costly to produce electricity from conventional types of the sources. Then after that, we will have to transmit conventional sources from its productive place towards the place where electricity is generated. Let us say coal will be there at Odisha and the plant is there in Ropar. So we will have to transmit that coal from Odisha to Ropar. So that is again this will be cause for the heavy transmission and distribution losses. Then after that, whenever we will just utilize these conventional types of resources, these will produce pollution, right? These will produce pollution. So this pollution will cause for the greenhouse effect, black hole, all that, right? So that means it will directly affect our health, health of the human being, right? So conventional sources may produce harms. I'm talking about particularly that nuclear. If we are using nuclear as a source for the electrical energy production, then that residual of the this chemical used in the that nuclear power plants, that are uranium, thorium, that will just basic cause for the disease like cancer, right? Another that in general, if I'm talking about that coal or petrol, that will produce some different kind of pollution. And again, pollution may be of any kind that will be harmful for the human being. And at the end, because there is a transportation, there is a distribution, all that will be a losses. So this type conventional types of the energy sources are also non economic in comparison with the ordinary types of the comparison with the non conventional types of this energy sources, right? This may cause for the if we are using continuously, if we are dependent on conventional types of energy sources, this may cause global warming, greenhouse effect, acid rain. Like these effects may be due to the fuel used for different types of the this conventional energy sources. Fine. This question may be asked in other term like advantages of the non-conventional energy sources. Yes, please. So this is the end of the lecture, right? If any problem is there, you may ask me.